All right, so we'll be looking at October, November 2010, variant 1, question 19. So go ahead and try it out by yourself. Okay, so question 19 says that the diagram shows the relationship between consumption expenditure and income, and they've given you options about APC and MPC, and they want you to figure out which one is correct. So, as we all should know by now, at least, that your marginal propensity to consume uh, was your change in consumption over change in income, which I'll denote with Y, and your average propensity to consume is simply consumption over income at whichever point, at a particular point that you take. So, one thing that should be a little obvious uh, is if you have consumption on your y-axis and income on your x-axis, then change in consumption is really your change in y. Change in income is really your change in x. And if you remember a bit of math, change in y over change in x was equals to your gradient. So the gradient of your line shows your MPC, which shows that your MPC it's a positive, it's a constant because it's a straight line, so it has a positive constant gradient. So that's basically what it's showing. Your APC, on the other hand, is when you take any particular point that you want to look at, you figure out the consumption from here, you figure out the income from here, and you simply divide consumption over income. Now, how does that help us solve this particular question? Well, if I take this point, let's go with this point. Let's call this point A. And for point A, if I first want to figure out the MPC, well, MPC we know would be constant throughout the line because MPC is the gradient of the line, and it's a line, so the gradient is constant. If it was a curve, then the gradient or the MPC would change, right? To figure out a gradient, you're simply going to look at your change in the x value, let's call this x, over the change in your y value, which we call y. And I've drawn this to show what change in x and change in y, if I start to think of it from point B, that is from where it intersects the y-axis. So anyhow, so your gradient would basically, in this case, be your y over x, right? Obviously, it's change in y over change in x. I've just denoted these two distances with y and x. If we look at what we need for your APC, well, for that you need consumption, which is the same distance as x, as we can see clearly from the diagram. So that is x, and we then need oh, sorry. Consumption is in the same. If we need consumption and income, but the x on the x-axis we have income, so the horizontal distance is the same, which means the income is the same. So income is going to be x because this is obviously the same as this, right? The horizontal distance. So the denominator we have x. However, if in the numerator, if you look at it, for consumption, for your MPC you only had this much, but for your APC you have all of this. This all shows you income, right? This vertical distance. So let's call, so it was y till this point, and let's call this point, I don't know, z. So your APC would be y plus z. You know, this entire distance being y plus z. Diagram got a bit messy, but hopefully it makes sense. So if you compare the two, it clearly shows that your MPC has a smaller numerator value. They both have the same denominator value, but your MPC has a smaller numerator value. Your APC has a larger numerator value. So this could be something like 5 upon 10, and this would be something like 8 upon 10. Clearly showing that if you're the numerator value of your APC, obviously if it's larger, then your APC as a whole would be larger, which is why we can conclude with that the MPC is less than the APC. And you can do this for any particular point. But the reason here is the fact, and if I can just quickly rub this, is the fact that you have a y-intercept. Since you have a y-intercept, you could do this for any particular point. You could do it for this point. You can see the change. You can see change in x and change in y, but when you that'll give your MPC. But because there is a particular positive y-intercept, when you go for your APC would have the same denominator value, that is x for income, but for consumption it would have y and it would have this distance as well for any particular point. So always your APC will be greater than your MPC in this particular line. So that, which is why you can go with D. If you want to look at the other options, the APC is constant. Well, not really, because it has an intercept here. So if you look at it something like this, if you picked a point with really close to the y-axis, then you would see that your denominator value, your income is very small, but your numerator value is very large if you compare the proportions. So here your APC would be large. As you go along the line, some point here it would not be as much, because then this head start that consumption gets from income, that wouldn't necessarily be very significant anymore. It would be constant if it was a straight line passing through the origin, though, because then no matter which point you look at it, the increase in consumption is like the same proportion of the increase in income, so it remains the same. And by that logic, we've already established how APC is decreasing, so it's obviously not rising. And another thing, if you look at this curve C1 that I've drawn, for this, the MPC would be equals to your APC. That is something one should know. And the reason being, again, if you look at it, if you want to calculate MPC again is gradient. It's calculated for this point. So you will look at change in X and over change in Y. And for your APC, you'd also look at consumption for that particular point and income for that particular point. So if it's a straight line going through the origin, for that case, MPC would be equals to APC. Since it's not, since it has a y-intercept, you can cross out C as well. So hopefully that makes sense, and hope that made sense, and hopefully that helped.